anyone ever tells you that sustainable aviation is a myth, it's just greenwashing, that nobody's actually doing it, tell them to hop over to ZeroAvia's website, because they are flying 100% sustainable aircraft already. This technology is out there, it's being flown, you can purchase it, you can order it, and it's been great to catch up with Dominic Weeks from ZeroAvia and hear all about it. Hope you enjoy the podcast. Dominic Weeks, thank you so very much for finding the time for us today. When you work in sustainable aviation, you feel a little bit like a time traveller. Walking around Farnborough, you see so many different technologies, and some of them are 10 years off, and some of them can actually be touched. So would you like to tell us a little bit about your company and also what we're stood in front of here?
Yeah, absolutely. So ZeroAvia is an American founded company originally in California about 2018, and the whole purpose of the company was to really tackle the climate impact of aviation in as far-reaching way as we possibly can. So we went back to first principles. Lots of our founding team are physicists, are scientists, and tried to assess what's the best way to do this. We have sustainable aviation fuels, and that's a pathway to tackle some of the impact. But we want to think about how we can do it in the most far-reaching way and also the most scalable, practical way. And for us, that's fuel cell systems. So we think we can deliver true electrification with fuel cells. The only emission is water vapor. You use a fuel cell system to create electricity. Electricity powers electric motors ultimately, and they turn propellers.
So you're basically generating your own electricity right at source where you need it, actually at the drivetrain, or?
Exactly. So you're generating electricity on the aircraft, and what you're really doing is you're finding a different way to store the energy as opposed to batteries, which essentially are fundamentally too heavy for commercial aviation and also have high cycling costs when you have to replace them. So with fuel cells, they last a really long time. We can store the energy in the hydrogen on board the aircraft as a fuel, and you can refuel the plane. And then you just create the electricity. Again, the only impact is water vapor. So we can improve the air quality impact. We can reduce the noise with these electrical systems. We can reduce the cost because there's less maintenance involved. And then we can also reduce the climate impact.
Excellent. And so what we're looking at here is actually a fuel cell then. So these 4 banks here are 4 generators of electricity, you could call them all.
Yeah, exactly. These are 4 fuel cell stacks. We are basically, what we've done, the innovation here, is these are commonly used in automotive applications, these types of fuel cell stacks. What we've done is we've taken all of the apparatus that makes them operate and keeps them happy, keeps them with the right humidification, the right temperature, and gives them enough oxygen. Yeah, so keeps them happy. And what we've done is we've made it common across multiple stacks. And that reduces the weight, it reduces the space, and it therefore makes them relevant and now allows you to fly an aircraft on them. If you can actually, I don't know if you see on the camera, but we're already, you'll see in some shots, we're already flying a prototype of this system, and obviously the electric motors and propulsion system as well there. We're flying that in a prototype, and we've flown 14 test flights. So we're demonstrating this technology in flight. It's not just here on the stand, it's actually flight demonstrated.
And that's exactly what I meant with the time travel. You're on one booth. We spoke to a different organisation this morning. They're building an incredibly large aircraft for a very specific use case, and that's something where they're really in the planning stages. So we interviewed somebody else this morning with an electric aircraft also in the planning stages, and then yourselves with something that's been in the air already.
Yeah, absolutely. I mean, coming to Farnborough is a great experience because you see all plastered across the the walls. You see aviation's history. It was one of the first manned flight in the UK. They had the balloon program, and this air show's been in operation for decades. I think now you're starting to see around the halls. You can look over there. I can see electric propulsion companies. I can see hydrogen-focused electric propulsion companies, and then of course ourselves. Airbus is big into this and is pushing it in the industry. Mm-hmm. So there's a big movement here. It's airlines. It's some of the biggest airlines, in fact. American, mm-hmm. Alaska, United are customers of ours. We announced a deal with KLM this week. So some of the biggest airlines.
Congratulations, by the way.
Thank you. Some of the biggest airlines, some of the biggest airports, and then also some of the biggest airframe manufacturers. So the industry is moving to these cleaner solutions.
Well, I know you've been here all week already, and there's a couple more days to go, and you've been talking all day. So if you like, maybe we can go and sit down. Then there's less going on in the background. You can tell us a little bit more about the company.
Sounds good.
Okay, Dominic, well, it's great to be sat down now, and I didn't realise that we'd be actually sat in front of so many famous names: Birmingham Airport, Schiphol, Nautilus here, Airbus, IAG. I mean, there's a lot of big hitting names, as you just mentioned to us outside, that you're working with already.
Yeah, we've got some really great partners, and I think it's testament to the flight testing we've done and how we've progressed the technology. So the important thing is, I mentioned it's not just about PowerPoint slides. This is not technology that is it's been flight tested, and it's also commercially been very attractive. So we have 2,000 engine orders from the likes of American Airlines, Alaska. You can see. United Airlines, and again I mentioned the KLM deal that we have struck this week to look at a demonstrator in an ATR. But we're also working importantly with some of the biggest players across the OEM landscape. So they're helping us with getting the technology ready for retrofit into their airframes.
Mm-hmm.
So having the likes of Airbus, Textron Aviation for the Cessna Caravan, MHIRJ for regional jets, de Havilland of Canada for some of the larger regional turboprops and the Twin Otter. So we've got that ecosystem ready. That means that we can support those customers, those airline customers, and we can have the engines certified and flying, we think, within a couple of years at the smaller end.
Well, actually, that's just what Progress Factor is all about, is this collaboration, the ecosystem that you speak about. Well, my favourite product that we have is called Progress x5. It's about getting 5 different companies to gamify target setting, and the way that they achieve the goals by collaborating more is fantastic. And my personal belief is everything we need to save the planet has already been invented. We just need to get people to work together, and it seems like you're proving that theory.
Yeah, I think so. I was just talking about this recently, is that what we've seen, I think, over the last 3 or 4 years in this space for hydrogen aviation is a lot more of the industry coming together instead of just working in their own silos. And it sends the right signal to investors, to governments, to the public at large that this is a viable pathway and we can actually end up with a clean future for flight. We can fly more. We don't have to fly with guilty conscience or with emissions. So working together is really important for that.
Excellent, that's really good. And behind you, you've got the artist's impression of the flight. Over here, on the other side, you're looking at a picture of an actual aeroplane that's been in the air. So what's the timeline? I believe you've got 2 different engines, or 2 different generators, I should call them.
Yeah. So 2 different engines or powertrains. We're targeting initially. So we're starting with a 600 kilowatt powertrain, which essentially would support about 10 to 20 seat aircraft. And we hope to have that certified by about 2026. And then at the same time, we're working on the underlying components and technologies for the larger engine, which is a ZA2000. So it's 2 to 5 megawatt modular powertrain. It can support 40 to 80 seat aircraft like a Dash 8 400 or an ATR. And these are the kind of aircraft that are flying passengers in and out of airports like Bristol to Dublin, for example. We used to have the Flybe aircraft buzzing around a lot in the UK, and all over Europe as well. So really popular airframes for passenger and cargo, even at this small regional turboprop end. Importantly, though, it doesn't just stop there. So we have a deal with MHIRJ to look at the CRJ application, so regional jet, and then we think that we can scale this technology in about a decade to support narrow-body aircraft. And at that point, with an A320, a 737, if you've got technology solutions for that category of aircraft, you're then tackling most of the emissions in aviation globally, because they're the workhorse of the industry. So it's going to have a huge application across different product sets. We just have to start small and go from there.
I mean, that's how the world always innovated. And if we see a lot of the stuff to do with decarbonisation, not just in the aviation sector, but there's a lot of companies out there that feel like they have to jump from first prototype to perfectly working solution. And let's face it, if we look at the car industry, how it's been optimized and developed in the last 100 years, we're not going to have that straight away in aviation. So like you say, you've got to start somewhere and move from there. This is a super short break and the only break in the podcast. I hope you're enjoying the interview. I'd just like to do a quick thank you to our sponsors, which right now is my own company, Progress Factors. If you'd like it to be your company and you'd like to become a sponsor of this series, then please do reach out and get in touch with us. There's all the contact information at the end of the film. Similarly, if you've got a great story to tell us and you'd like us to do a podcast with you, then please contact us and tell us what you're doing to save the planet and how you're integrating wonderful working practices into your business model. And finally, if you'd like us to help you to accelerate your own agenda and to earn more money through doing the right thing, then once again, please check out the end of the film where there's all the contacts to us, or the end of the podcast, depending whether you're watching this on YouTube or listening to it on one of our streaming services. If we look at your website, it's not just about both of the fuel cell generators or the powertrains that you're selling, but also hydrogen's on there as a product and composite components as well, I believe, or?
Yeah, so we're not developing, we're not a hydrogen producer, but what's really important for us is to make sure that the airlines will have hydrogen to provision their powertrains. They'll have the fuel available to be able to fly the missions when we have the engine certified. And we think it's really important that we take a leading role in establishing the concept of operations. So we're working with some of the largest airports in the world, the 3 largest airports in Canada, for example. We're working with Aéroport de Paris Group, and then we're working with a number of UK airports as well, Birmingham International, as you mentioned, and then Aberdeen, Glasgow and Southampton. And with these airports, it's hugely important for us to showcase how the aircraft will actually get refueled. So we have some technological solutions we're developing for mobile storage and distribution of hydrogen, and we also have some smart hydrogen production software. So we are playing a role in that space, but we need a big coalition of partners to come in, including the energy majors, to deliver the amount of fuel that will be needed for all hydrogen flights that we see will be online before 2050. It's going to be a lot of hydrogen. It needs a huge ecosystem. It needs the big players.
But again, thinking about it, if I compare that to the story of cars, I mean, I was just reading an article recently about why hydrogen didn't take off in the States, and it was purely down to exactly that. There were no, refueling stations. But at least with airports, we have less of them. It's not like a BP or a Shell fuel station here. It's actually, we're talking about something where it's only a few thousand around the world, I guess.
Exactly right. And I'll take the UK as an example. 61 airports that you would likely target with a hydrogen refueling capability, as opposed to many thousands of electric vehicle charging points that are needed, or hydrogen vehicle refueling would be needed, petrol stations. So there's definitely less. The infrastructure spend is concentrated, and there's a big opportunity for airports, once you have that anchor demand of aircraft to travel, to act as hubs for hydrogen. So decarbonise their own operations, clean up the air quality of their own operations using fuel cell technologies for power, whether it's ground equipment, what have you, and then also proximate industry can draw from that hydrogen demand, and have good economies of scale there. And on with transport, we're seeing more hydrogen buses, we're seeing hydrogen trucking, heavy duty trucking using hydrogen fuel cells. So it can extend the capabilities of electrification beyond the EV cars, where obviously batteries work really well.
Yeah, absolutely. And just tell me, if we stay with the technology, so if we look at hydrogen, I mean, I come out of the car trade originally. The reason I live in Germany now is I moved there to work for BMW. Back in 1998, fuel cells were not a new technology. It's not that we're looking at something that's just been invented 2 or 3 years ago. But I do remember BMW having 7 Series combustion engines. So they basically had 7 Series that were running around with hydrogen-powered combustion engines. That was available, the turn of the century. Why have you guys gone for the fuel cell and not the direct burn version of hydrogen?
Yeah, there's a number of reasons. I think that the one is that's particular to aviation, although it does have an impact on the ground as well, is the fact that you have non-CO2 emission impacts as well. So nitrogen oxides, which obviously are an air quality impact at and around airports than they are on roads. Particulate matter, the same story there. But then you also have a number of different impacts when those combine in terms of the contrail formation. So soot is an emission plus the PM, and that helps contrail formation with the ice crystals. So non-CO2 impacts are thought to be in aviation 2/3 of the climate impact, which is a pretty unique case. So you need to try and tackle that full climate impact, and that's why fuel cells offer you the opportunity to do that. Just low temperature water vapour, which you can potentially manage. So that's why we're focused in that direction. We think that it's the cleanest way of doing it. Also, a key thing with hydrogen is it's a very light fuel. It's got lots of advantages, but it takes up a lot of volume. So about gaseous compressed hydrogen at 350 bar is about 8 times worse than kerosene for the amount you can store of energy you can store on an aircraft. With liquid hydrogen, you get to about 2.3 times better than that, so it's closer. But when you've got a challenge with volume, you want to use that fuel as efficiently as possible. And as you'll know from the automotive sector, fuel cells are getting up to about 60% efficiency. Combustion engine, in the best case, is 30%. So it's double the efficiency, you need half the fuel. And so that's another good reason why it's a better use case. I'll give a third if that's okay.
Please do.
Because combustion engines operate at really high temperatures. And there are a lot of wear and tear, a lot of moving parts. With a fuel cell system and an electric propulsion system, you have much less of that, and just like with an electric vehicle, you have far fewer maintenance. I had an Uber driver who was driving a Tesla, and he had 50,000 miles. He told me he'd never taken it to the garage, which I thought was really interesting. Similar concept for airline operators. They just have to do much less maintenance, and that's 25% of their costs.
And it's also an impact on the environment as well, and that's what I love about Progress. That's why the company's called Progress Factors. Is once you make one improvement, you end up finding the next improvement after that, and it's wonderful to hear these stories. And what really delights me about your story as well is when you talk about retrofit, because as we all know, the aviation sector is doing a lot to decarbonise. And when I hear targets for 2050, all we do with our clients is help them to achieve things quicker in a more motivational way. And what you're actually doing is you're saying we can have an impact in 2026, we can have an impact in the next few years, and not wait for somebody who paid 25 million for an aircraft to use that up before they buy the next thing that's a lot greener. So it's actually using the existing fleets and making them more sustainable.
Yeah, absolutely. I mean, there is big advantages when we can get some clean sheet airframes that are designed specifically for these systems, but certifying an airframe and a propulsion system at the same time is not a trivial endeavour. There are aircraft flying that we can retrofit, and we can have an impact much sooner. So that's the exact reason why we're pursuing the retrofit model, and we expect to be able to having a real world impact in the next couple of years.
Dominic, it's been so motivating speaking to you today. I really appreciate that you're taking the time. I want to be careful with your time as well, because I know you've been talking to all sorts of people all day long, and you've got a couple of days ahead, I guess. Are you still at the show tomorrow as well, or?
Yeah, we're here all week. It's a fantastic opportunity for us. We've met a lot of industry stakeholders. Tomorrow there'll be members of the general public, and there'll be a lot of young people. It's the Pioneers of Tomorrow Day. So it's a great opportunity for us to tell them about what is coming. When you've got aspiring aerospace engineers, it's great for them to get their eyes on the technology and see it, and I think of employment.
Yeah, and it's so motivating as well to see. I mean, we were watching one of your films running on the show stand just here earlier on, and really, I think there was a quote there from Bill Gates that flying was the first World Wide Web. It was the first thing that actually connected people around the world. There are people out there at the moment that are saying we shouldn't fly anymore. I don't sign up to that, and it's wonderful to see a company like yours that is actually making it possible for the next generations to fly with a very good conscience.
Yeah, I think one thing to say on that, we've had about 10% of the world's population has ever been on an aircraft, and if you think about the amount of change that we've seen post Second World War in terms of development, and a lot of that's come through connection. A lot of it came before the World Wide Web was invented, and if you can extend that to more a broader swathe of the population, we can have really positive impacts, connections, social, cultural, economic. So we think we need to fly more. We just need to find ways to do it in a clean way.
Excellent. Well, it sounds like everyone's talking to you already, but I'd like to just offer you one last opportunity. Thank you for taking the time for us. Is there anything that this podcast can do for you? Is there anything that this film can help you with, at ZeroAvia? Who would you like to reach out to you? What message would you give out there to other companies, interested parties, maybe students that should be doing internships, whatever? Who would you like to come and collaborate more with you?
Yeah, I think the message is just to be ready for a new way to fly and to be excited about it, because it can make a big difference, and you can take away a lot of that the flick scam, the guilt with flying. So yeah, just love your audience to be enthused and interested, and so visit our website, get in touch with us. If you have questions, we're always glad to hear from people who are interested.
Excellent. And before I embarrass myself, I'm going to ask you to say what the website is. I think I know, but I'm going to get you to do it before I embarrass myself.
Yeah, so it's ZeroAvia.com, so simple.
I would have guessed right. Anyway, Dominic Weeks, thank you so much for your time.
Thank you very much.
So I do hope you enjoyed listening to that podcast as much as I enjoyed actually interviewing the people that we spoke to today. As we mentioned halfway through the film, if you'd like us to support you and accelerate your own sustainability agenda, or if you'd maybe like to sponsor this podcast, or if you just got something you'd like to chat to us about, which maybe could become the next podcast, then please do go over to either our LinkedIn profile. You can find us at Progress Factors, or my own LinkedIn profile is Nick Stanforth. Or you could also just go over old school to our website, which is www.progressfactors.com. Thanks for listening, and tune in for the next podcast as they keep being released.